Good morning, evening, afternoon, night, wherever you're watching this from. So today on our topic of fun scholar entire chapter concept, so we are going off with ICSC class 8 exponents and powers. Okay, so let's start the chapter. So first is exponents and powers, the name of the chapter. Let's begin. So first, let us understand why do we need exponents? Okay, so exponents are required in order to make sure that we can, like, if something is huge, something that we already know, like if we need to travel from Delhi to Kolkata, for example. We have to cover, like, for example, 4,000 kilometers and something like that. But if, like, I tell you a random clause where we have to cover from, I think, from Delhi to the moon or to Jupiter, then the distance covered will not be measured in kilometer. That distance will be covered in the power of zeros. That zero exponentially increases, keeps on increasing and increasing. That is how the power system of exponents came into being. So let us do some very basics on what are exponents. Okay, so 10 to the power 1, see, it is read 10, superscript 1 is read 10 raised to the power 1, that is 10. 10 raised to the power 2. What is that actually? We are writing 10 and multiplying with 10 again. Okay. Similarly, 10 to the power 3 is 10 into 10 into 10. Okay. 10 to the power 4, 10 to the power 5, whatever raised to the power that is, we are going to write that particular, like, 10, that number of times. Similarly, we will explain number of zeros. So as it is written here 10 to the power 6, so we are writing 6 zeros with it. 1, 2, 3, 4, 5, 6, 6 zeros. Okay. So let us go to some daily examples of how to do it. Area and volume. Exponents are used to calculate areas and volumes. Okay. So for example, if I give you guys a small example, like if I say, we all know what is the area of a square. So area of a square is equal to side into side. So if I say the area of, like, let me draw a square here, small square. If I say the side of one, the length of one side is 10 to the power 7 centimeter. Okay, 10 to the power 7 centimeter. So it's a huge value, right? So then the distance will come in like what? The area is 10 to the power 7 into 10 to the power 7. Now the answer is going to be 10 to the power 14. But why did we add these two? What is base? What is raised to the power? Everything will be covered in this particular session. Okay. So next thing is that computer large computing numbers. So we all know that we have some GB of space. So GB is known as gigabyte. There are the lowest unit that can be measured in case of a computer is a bit. So few bits make a byte, a few bytes make a kilobyte, a few kilobytes make a megabyte, a few megabytes make a gigabyte, a few gigabyte makes a terabyte. It goes on increasing like that. Okay. So in order to make sure that we understand everything about, like, how exponents are used, we need to understand the basic synopsis and the rules of exponents. Okay, we'll be covering everything one after the other in this particular lecture. So first we have a few videos. Okay, the first video is about power of 10. Okay, let's go to the video and watch it. Second.
interesting questions. Well, I have to warn you that the answers are pretty long. Here's the first one. What is the speed of light? The answer. It's 300 million meters per second. There are 8 zeros. That's really fast. Now, if you think this answer is huge, let me ask you the second question. What do you think is the mass of the sun? You may have to wait really long for this. And I'm sorry, I don't think I even know how this number is pronounced. It took me 8 seconds to write the answer, and as you can see, there are 27 zeros here. It's obvious that such huge numbers are not only difficult to read out, but are also not written easily. So there has to be a simple notation for such huge numbers. Consider a small number first, say 5,000. Let's look at a different way to write it. We can also write it down as 5 multiplied by 1,000. In this step, we just separated the zeros from the number. Now we should try to write this number in the exponential form. 1,000 can be written as 10 multiplied by 10 multiplied by 10. This equals 10 raised to 3. So we can write 5,000 as 5 multiplied by 10 raised to 3. This is just a different way to write 5,000. Some of you might think that 5,000 looks far better than 5 multiplied by 10 raised to 3. In this case, yes, there was no need to write 5,000 this way. In the next example, you will understand the real need for such notation. But before we move on to the next example, let's review what we just did. First, we split the zeros and wrote 5,000 as 5 multiplied by 1,000. Look at the exponent 3 here. It actually depends on the number of zeros in the number. So what we did next was count the number of zeros. And we got the answer as 3 zeros. And in the last step, we write it down in exponential form. 5 multiplied by 10 raised to 3. Now let's consider the speed of light without the units, 300 million. The first step asks us to split the zeros. So we write it down as 3 multiplied by 100 million. Then we count the number of zeros. There are 8 zeros in 100 million. And then we write it in an exponential form as 3 multiplied by 10 raised to 8. So the speed of light can be written as 3 multiplied by 10 raised to 8 meters per second. We can see it is much simpler to write it in terms of powers of 10. We don't have to write large numbers. It's easier to read the number out, and the chances of making a mistake are also lower. Remember, split, count, and exponential form. There is just one more thing we need to keep in mind when we solve such examples. Consider the number you can see on the whiteboard. It's actually 2.33 billion. Let's try and write this number in terms of powers of 10. We follow the same steps we followed in the previous example. We split the zeros, count them, and write it in exponential form. Separating the zeros, the number can be written as 233 multiplied by 10 million. And since there are 7 zeros in 10 million, we can write the number down as 233 multiplied by 10 raised to 7. This answer is correct. But this is not the best way to write the final expression. There is a small point we need to remember here. The number which is multiplied to the power of 10, in this case 233, should have just one digit before the decimal point. Where's the decimal point here? 233 can also be written as 233.0. So it has 3 digits before the decimal point. To get just one digit before the decimal point, here is a trick. We can write 233 as 2.33 multiplied by 100 and 10 raised to 7 as is. So the number will equal 2.33 multiplied by 10 raised to 2 multiplied by 10 raised to 7. We can remove the brackets and write it as 2.33 multiplied by 10 raised to 2 multiplied by 10 raised to 7. Look at these two terms now. 10 raised to 2 multiplied by 10 raised to 7. The base of both the numbers is the same. It's 10. Hence, we can use the product law and write it as 10 raised to 2 plus 7. We add the exponents over the base. That equals 10 raised to 9. Hence, this big number can be written as 2.33 multiplied by 10 raised to 9. So the basic steps are very simple. We split the zeros, we count the number of zeros, and write it in exponential form. And we make sure that this number here, which comes before the powers of 10, has just one digit before the decimal point.
Okay, so this is the first video. We have a few videos attached to this. So we have part 2 and part 3. Before moving on with that, I need to explain a few basics part. Okay, so for example, let me take any number. Let me take 1.35 into 10 to the power 5. Okay, so this number is actually what it is, 135 into 10 to the power 3. Okay, which is actually equal to 135 1 2 3 zeros. Okay, so this is the exponential form, counting zeros and total numerical value. Okay, but let's take this particular thing in account now. 10 to the power 10 raised to the power 5, in this particular concept, this 10 is known as the base. Okay, so if I write here 5 raised to the power 2, this 5 is going to be the base. Okay, so base is anything that we have to multiply how many times? The power number of times. Okay, so this 10 to the power 10 raised to the power 5 is actually nothing but 10 into 10 into 10 into 10 into 10. So we are writing 10 how many times? 5 times. This 5 is actually the power of what? Of the base. Okay. So if I tell you one more thing, if I write something like this, a to the power b. Okay. So here it's what? This a comes out to be the base and this b comes out to be the power. How do we pronounce this? We say a raised to the power b, a raised to the power b, 5 raised to the power 2, 10 raised to the power 5. Okay, so this was the very basics, but there is one more thing. Okay, so there is a difference between 2 to the power, one second, 2 to the power 2, okay, and 2 to the power 2. In this particular record, this is something that is known as 2 to the power 2 to the power 2. This is known as 2 into 2. This particular portion is not required right now. Okay, this will be doing in a different class altogether. So I'm just rubbing this. So we will always write the superscript in the right hand side direction. Superscript right hand side direction, that means this is the power. To the power 2, this is the power, and this is the what? Base. Okay, so as this is clear right now, so what is base and what is power, how to write this, everything, we'll move on to the second video now. Okay, let's start on with the second video.
In the previous videos, we saw how we could write large numbers using powers of 10. But the powers of 10 can also be used to write really small numbers. Here is a practical example of a small number. What is the diameter of an oxygen atom? This is your answer. 0.000, many more zeros, 356 millimeters. The steps to write this in powers of 10 are similar to the steps we used in our previous videos. Let's look at an example to understand better. 0.00035. First, we split the number. Here, since we have a decimal point, the zeros will come in the denominator. This tiny number can be written as 35 divided by 100,000. We just wrote this decimal number in the fractional form. In this 100,000, we just count till we reach the last non-zero digit after the decimal. So 1, 2, 3, 4, and 5, hence 100,000. Then we count the number of zeros in the denominator. There are 5 zeros. Then we write this in exponential form. So we write this as 35 divided by 10 raised to 5. The next part is interesting. In the video based on negative exponents, we learned that 1 divided by 10 raised to 5 can be written as 10 raised to minus 5. This expression is actually equal to 35 multiplied by 1 upon 10 raised to 5. Hence it equals 35 multiplied by 10 raised to minus 5. When we got this from the denominator to the numerator, we just changed the sign of the exponent. This answer is an exponential form. Can we leave it at that? No. In the previous video, we learned that the number multiplied with the powers of 10 should have just one digit before the decimal point. The number 35 is actually 35.0, which means it has two digits before the decimal point. Hence, we have to write it in such a way that we have just one digit before the decimal point. So 35 can be written as 3.5 multiplied by 10. And we write 10 raised to minus 5 as is. We can use the product law to write 10 multiplied by 10 raised to minus 5 as 10 raised to minus 4. Hence, we get the final expression as 3.5 multiplied by 10 raised to minus 4. So 0.00035 can be written as 3.5 multiplied by 10 raised to minus 4. Now we can try to write the diameter of an oxygen atom in the same way. The diameter of an oxygen atom is these many millimeters. In the first step, we split the number and write it like this, with many zeros in the denominator. Since the last non-zero digit comes after 16 places, we have 16 zeros in the denominator. Hence, this can be written in exponential form as 356 divided by 10 raised to 16. And this number can be written as 356 multiplied by 10 raised to minus 16. The number 356 has 3 digits before the decimal place. We write it in such a way that we have just one digit before the decimal point. Using the same rule we studied before, we can write 356 as 3.56 multiplied by 10 raised to 2, and 10 raised to minus 16 is written as is. These two numbers have the same base, and since they are multiplied, we can use the product law and add these exponents. That gives us 3.56 multiplied by 10 raised to minus 14. This makes it so much simpler. We can just say that the diameter of an oxygen atom is 3.56 multiplied by 10 raised to minus 14 millimeters. In the previous videos, we saw how we could write large numbers using powers of 10. If we have a number like 753,000, we can write it as 7.53 multiplied by 10 raised to 5. But how do we convert the other way around? Like if we were given this, how do we get this? This conversion is far simpler as compared to this conversion. Let's look at an example. Say 4.53 multiplied by 10 raised to 4. All we really need to do is look at the power of 10. Actually, the sign of the power of 10. In this example, we can see that we have a positive power of 10. The positive power of 10 simply tells us that the number of places the decimal point moves to the right. In this case, the power of 10 is 4. The decimal point of which number moves to the right? Yes, the number which is multiplied with the power of 10. In this case, 4.53. So we write 4.53 and move the decimal point 4 places to the right. Moving it once, we get 45.3. Moving it the second time, we get 453.0. Moving it the third time, we get 4530.0. And the fourth time, we get 45,300. Hence, 4.53 multiplied by 10 raised to 4 is equal to 45,300. What about the numbers with negative exponents or negative powers of 10? Do we follow the same procedure? Let's see. Consider the number 4.53 multiplied by 10 raised to minus 3. In this case too, we see the sign of the power of 10. We have a negative power of 10 here. The negative power tells us that the number of places the decimal point will move towards the left. Remember, positive power right and negative power left. In our example, the power is minus 3. It means we have to move the decimal 3 places to the left. We move the decimal point of the number 4.53. Moving it once to the left, we get 0.453. Remember, we are moving the decimal point towards the left. Don't get confused with the directions of the arrows. Moving the decimal point again towards the left, we get 0.0453. And moving it leftwards for the third and the final time, we get 0.00453. Hence, 4.53 multiplied by 10 raised to minus 3 is equal to 0.00453. As I said before, this conversion is simpler. Positive power, decimal to the right, and negative power, decimal to the left.
Okay guys, I hope you understood all of the videos where we have like signified everything. Now we'll be going straight to the next part of the chapter. See, this we have already explained: 10 raised to the power 2, base, exponents, and this is called power of 10. So 10 raised to the power 2, we have already decided that no point wasting time in this. Now let's go to our first example that is given. If n is a whole number and a is any number, n is a whole number. If we take 0, anything, and if 0 is there, 0 raised to the power 100, the answer will be 0 only. Okay. Now, if I take a value like this, for example, it's given here 5. So 5 I multiplying 7 times. So 5 into 5 into 5 into 5 into 5 into 5 into 5, 7 times. So the base here is 5 and the exponents is 7, which is also known as the index. Okay. So if the base is minus 3, base can be negative as well. So if I say something like this, so if I say something like this, like minus 3 raised to the power 4, minus 3 raised to the power 4, that actually signifies minus 3 into minus 3 into minus 3 into minus 3. Okay, now let's solve this part. Minus into minus, that will give, this will give us a positive answer, right? This will be 9, right? Similarly, these two will also give us a positive answer, that is 9. So from negative term we get a positive term. So how can we realize that without even calculating this, the answer is going to be in positive? Because if the power is even, it is going to be positive. If the power is odd, for example minus 3 raised to the power 5, this will be odd. And the answer will be what we have already solved till 81, right? So 81 was positive into minus 3. and the answer will be minus 3 to 43. Okay, so if the power is even a negative number integer will give us a positive outcome. If the number is odd, we'll get a negative. Okay, if the power is raised and the power is odd here, we'll get a negative. Okay, so this was all about the basics. Now let's head on to the next portion. So first sum we will be doing. Okay, I'll give you like some time, like 5 seconds to read what is written. So if a is equal to 3 and b is equal to 2, then we have to find out values of 2. One is a raised to the power b plus b raised to the power a raised to the power a plus b raised to the power b. Okay, we'll do it one after the other. So firstly, I'll solve this a to the power b. So I'm writing it in the top portion of the screen, a to the power b plus b to the power a. Now it's time for us to substitute the values. It's already given in the question that a is equal to 3. So in place of a, I'll write 3. So 3 raised to the power b. So b is nothing but 2, right? 2. Similarly, b is again 2 and a is 3. So we have to solve nothing but this. Okay, now let's solve this. 3 in 3 raised to the power 2. That means 3 square. 3 square is going to be nothing but 9. Okay, and 2 raised to the power 3. 2 into 2 into 2. Right. So 2 into 2, 4. 4 into 2, 8. So the next step will be 9 plus 8 gives us the answer nothing but 70. So the answer of the first one is going to be 70. Now let's go into the next one. I'm solving it here. So a is 3, right? So 3 to the power 3 plus 2 to the power 2. Okay. So 3 to the power 3 is nothing but 3 into 3 into 3. So 3 3s are 9, 9 3s are 27. 2 square is nothing but 4, right? So the answer comes out here as 31. So we have solved the first two sums now. Okay. I hope you understood this. Next, let's move forward. Okay. So we have already done this. Now, what is the product law of exponents? Okay, before going on to the video, I will be trying to explain this law in a very easy manner. Okay. So if I have something like this, always remember product law holds true for the same base purpose. Base has to be same. Okay. So if I write 5 raised to the power 3 multiplied by 5 raised to the power 8. Okay. So and then 3 raised to the power 4. Okay. So the first two terms have the same base. Okay. So if I have the same base, their powers are added. Same base, powers are added. So we can write 5, 3 plus 8 into 3 to the power 4. Okay. So same base. 3 is a different base than 5, right? So we cannot be using product law on this. So this becomes nothing but 5 raised to the power 11 into 3 raised to the power 4. Okay, same base only we can apply product law. Now let us signify one more thing. If I write something like this, 10 raised to the power 3 into 10 raised to the power 7 into 10 raised to the power minus 8. I'm writing minus sign here. Okay. So 10, 3 plus 7 minus 8 directly. Directly we can write that. Okay. There is one more thing how to solve this. As this is 10 only, let me solve it in the very common manner. So 10, 100 into 1, 2, 3, 4, 5, 6, 7 divided by, so this term is actually what? 10 minus 8 is equal to 1 by 10 to the power 8. Okay, so I'm writing this 1 2 3 4 5 6 7 8. Now it's time for us to cancel out all the zeros. So 1 2 1 2 1 2 3 1 2 3 1 2 1 2 1 1. The answer comes out to be 10. Now let's solve this portion. So 3 plus 7 is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, 1, 2, 3, 4, 5, 6, 7. 3 plus 7, 10 minus 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. So here it will be so one more zero. I have done one thing. So I've written here 10 to the power 3 in the first one. I've written 10 square ka value. Okay. So I've add one more zero here. So the answer will be 100. Okay. So this is how we can solve this. So now it's time for us to look at the video again. Let's see what is the product law.
Now that we have studied the basics of exponents, let's understand a few laws related to exponents. We know that 2 raised to 2 is 2 multiplied by 2, and 2 raised to 3 is 2 multiplied by 2 multiplied by 2. In the first case, we multiply two 2's since the exponent or the order is 2. And in the second case, we multiply three 2's since the exponent is 3. Now let's say we want to multiply 2 raised to 2 with 2 raised to 3. Observe that the base in both the cases is the same. It's 2. This can actually be solved in two ways. Let's see the first way. 2 raised to 2 can be written as 2 multiplied by 2, and 2 raised to 3 is 2 multiplied by 2 multiplied by 2. And this can be written as 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2. Since 5 2's are multiplied, this product can be written as 2 raised to 5. What we did here was simple. We just expanded the exponents. We wrote it in the simplest form and then counted the number of 2's in the end. Now let's see another way of doing it. The base in both the cases is 2 and the exponents are 2 and 3. So this can directly be written as 2, which is the common base, raised to 2 plus 3. The sum written here is the sum of the exponents 2 and 3. We kept the base same as the base in both the cases and just added the exponents. This is called product law, and this expression equals 2 raised to 5. We get 5 here since the sum of 2 and 3 is the exponent. This method in which we can add the exponents of two numbers with the same base is called the product law. Also remember that what we are finding here is actually the product of two numbers. So when you see two numbers with the same base being multiplied with each other, you can conveniently use the product law. Also observe that the product law has made our life much simpler. We avoided writing so many twos and got the correct answer in just one step. Now let's try and reduce it to the general form with variables. So the product law says a raised to m multiplied by a raised to n gives us a raised to m plus n. Again, remember that this law holds true only if the base of both the numbers is the same. This law holds true in all cases, but may not hold true when the base is 0. So remember, the product law says a raised to m multiplied by a raised to n gives us a raised to m plus n if a is not equal to 0. So when we are multiplying two numbers with the same base, we should add their exponents. This is the product law. So let's try out a few problems using the product law. The first problem asks us to express this in exponential form. 3 raised to 7 multiplied by 3 raised to 14. Since these two are multiplied and have the same base, we can use the product law. called the product law. It's simply because it deals with a product of two numbers. Using the product law, we can write this as 3 raised to 7 plus 14, which gives us 3 raised to 21. If we did not have the product law, we would have to write 21 threes in our notebooks to arrive at this final answer. Let's get the next problem. 5 raised to 78 plus 5 raised to 24. Using the product law, this can be written as 5 raised to 78 plus 24, which equals 5 raised to 102. Correct? Wrong. Yes, the base is same, but notice that we have an addition sign here. And product law can be used only for multiplication or product as the name says, not for any other operation. What about 5 raised to 4 multiplied by 6 raised to 4? We cannot use the product law here since the base is different. Base here is 5 and the base here is 6. It doesn't matter if the exponents are the same. If the base is different, the product law cannot be used. But can only two numbers be multiplied using the product law? Not necessarily. If we have an expression like 4 raised to 3 multiplied by 4 raised to 2 multiplied by 4 raised to 5, we can use the product law. Same base and product. So this can be written as 4 raised to 3 plus 2 plus 5, which equals 4 raised to 10. So the product law says that while multiplying numbers with the same base, add their exponents.
Okay guys, so this was all about what is product law. Next, quotient law, and after that, what is the power law? Okay, so quotient law. Okay, let's go. Let's head straight into that. Okay, one second, guys. So when we have what is the quotient law? We already know what is quotient, right? The ones that is always up. So let's do one thing. Okay, let's head into the videos first and let's watch the videos about what is quotient law and the power law. After that, I'll explain this again. Okay, but first, if you watch the video, then you can realize what are the different concepts first. Okay, so let's head on with the quotient. What are quotient? Quotient law. Okay, see, this is the quotient law. Power law. See, remember one thing, quotient law we have already covered a little bit part. So if I say we have already done this, right? 10 raised to the power 7 into 10 raised to the power minus 8. Okay, so we have already done 10 to the power 7 divided by 10 to the power 8. This particular portion is nothing but the quotient law. It is written power law here, but we are doing the quotient law first. Okay, see, again the bases have to be the same. It is 10 here, right? 10. So as the bases are same, so we will always move towards either towards denominator or towards numerator. So let's do it separately. So one time towards numerator, so 10 raised to the power 7 minus 8, or 10 1 by 10 raised to the power 8 minus 7. Okay, so this will give us nothing but 10 raised to the power minus 1, and this will give us 1 by 10 to the power 1, which are absolutely the same. This is what quotient law is all about. Now, power law. Okay, power law means that when I have a value, for example 2 raised to the power 5, and I'm multiplying it with a different value like 7 raised to the power 5. Okay, so here in case of power law, the name suggests it's a power, right? So power of both of them are the same. Then I can write here 2 into 7 raised to the power 5. Okay, so this will become 14 raised to the power 5. Okay, if I write this in variable format, what is going to be the power law now? A to the power b into c to the power b is equal to ac to the power b. Okay, so This is all about the three different laws. Now let's watch the video regarding these laws.
In the previous video, we saw how product law was applied to a product of two numbers with the same base. Let's try dividing two numbers with the same base. 3 raised to 5 divided by 3 raised to 3. Again, remember, we are performing operations on numbers with the same base. Here, the base of both the numbers is 3. There are two ways in which we can solve this. 3 raised to 5 can be written as a product of 5 threes. So this would equal 3 multiplied by 3 multiplied by 3 multiplied by 3 multiplied by 3. And 3 raised to 3 can be written as 3 multiplied by 3 multiplied by 3. Looking at this expression, we can cancel out 3 threes from the numerator and the denominator, and what we are left with is 3 multiplied by 3. This can be written as 3 raised to 2. Now let's look at a simpler way. The base in both the cases is 3. So we can directly write 3 raised to 5 divided by 3 raised to 3 as 3 raised to 5 minus 3. So we kept the base as 3 and subtracted the exponents over the base. This method in which we can subtract the exponents of two numbers with the same base is called the quotient law. This also gives us the same answer, 3 raised to 2. So we can generalize the quotient law by saying a raised to m divided by a raised to n equals a raised to m minus n. But wait, we missed something important. In this example, this is called the dividend and this is called the divisor. Observe that the power of the dividend is greater than the power of the divisor. Well, here's another example to understand why this observation is important. 7 raised to 2 divided by 7 raised to 4. In this case, notice that the power of the dividend is lower than the power of the divisor. 2 is less than 4. There are two ways of solving this example too. This would equal 7 multiplied by 7 as the exponent is 2, and this would equal 7 multiplied by 7 multiplied by 7 multiplied by 7 as the power is 4. Cancelling out two sevens from the numerator and the denominator, we get the answer as 1 divided by 7 raised to 2. The easier way to get to this answer is by writing this directly as 1 divided by 7 raised to 4 minus 2. This is also the quotient law, but it was a little different this time. We subtracted the exponents, yes, but this time we kept the number in the denominator. We wrote it as 1 divided by 7 raised to 4 minus 2. This 7 is same as the base in both cases, and we subtracted the exponents over it. This gives us 1 divided by 7 raised to 2, the same answer we got earlier. So the quotient law says a raised to m divided by a raised to n gives us 1 divided by a raised to n minus m, with a condition that says m less than n. In the earlier case, we wrote m minus n. This time we wrote n minus n, but under a 1. One easy way to remember this is that no matter what, you will always get a positive exponent. In the second example, to get a positive exponent, we had to subtract 2 from 4, hence n minus n. For the earlier formula of quotient law, the condition says that n is greater than n. If the exponent of the dividend is higher, we simply write it like this. If the exponent of the dividend is smaller, we write it as 1 divided by this. This law is satisfied in all cases except when a is equal to 0, because we cannot have 0 in the denominator. So 8 is not equal to 0 is another condition we should remember. The examples will help you understand better. Let's try solving solving 6 raised to 9 divided by 6 raised to 3. In this case, the base is the same and the exponent of the dividend is higher. So we are looking at the first case here. Hence, we write this as 6 raised to 9 minus 3 using the quotient law. That gives us 6 raised to 6. Here's a second example. 17 raised to 12 divided by 17 raised to 21. Here, the exponent of the dividend is lower than the exponent of the divisor. Hence, we use this formula and write it as 1 divided by 17 raised to 21 minus 12, which gives us 1 divided by 17 raised to 9. Observe that the formulae are made in such a way that we always get a positive exponent. Now try dividing 4 raised to 4 by 3 raised to 2. Can this be solved using the quotient law? No, since the base in both the cases is different. The quotient law says that by dividing numbers with the same base, subtract their exponents. If you already know what negative exponents are, then this one formula would suffice. But we use the second formula since we haven't come across that topic yet.
Okay, so now I'm not going to waste any more time on looking at the power law. We've already understood what is power law. If not, let me repeat myself again. If I have any two numbers, for example 17 raised to the power 9 into 17 raised to the power 5 into 17 raised to the power minus what minus 13. Okay, after that into 2 raised to the power just 2. I think that will be enough. Okay, so first thing what we have done, first product law, right? So using product law we can write 7 9 plus 5. I've just used product law. Now till now I'm writing rest of the sum. Okay, so what is going to be this 17 raised to the power 14, right? And now I'm using what quotient law, 17 raised to the power 13, and this I'm leaving it as it is. Okay, as numerator wala power is greater than denominator wala power, so for this particular instance I'm going to write 17 14 minus 13 into 2. Okay, so 17 to the power 1 into 2 raised to the power 1. So the answer comes out over here as 34. So this we have utilized every law. Power law, okay, quotient law, sorry, power law here, quotient law here, quotient law, this is product law, and this is the power law. Okay, now for this sum you have already realized that 7 raised to the power 1 into 2 raised to the power 1, both of the powers are same. So if I write something much more easier, like 2 raised to the power 4 into 3 raised to the power 4. Okay, power law states that if both of the powers are the same, then we can write 6. 6 is what? 2 into 3, 6 raised to the power 4. That's it. Okay, so let's continue with the sums now. Okay, so this is the product law, this is the quotient law, this is the power law. So oh, one more thing about the power law I forgot to tell you. Let me write it down. So if I have 7 to raised to the power 3, 7 to the power 2 into 3, so that is nothing but 7 2 into 7 2 into 7 2. Okay, so that will give us 2 plus 2 plus 2. That is nothing but 7 raised to the power 6. Okay, so this can be also written as 7 2 into 3, that is 7 raised to the power 6. Okay, this is also a portion of power law. Okay, now let's continue. Okay, for any non-zero number we have already done this. A raised to the power n is equal to, so if I have a positive number, if I write 10 to the power 7. Okay, if I'm going to write this in inverse form, we'll write 1 by 10 to the power minus 7. This, both of them are equal. If I have a number 10 to the power minus 5, I can write this as 1 by 10 to the power 5. Okay, so these both are equal. Okay, and one more thing, any value, any value, any value 7, 8, 1, 2, 1, 3, 5, anything raised to the power 0 will give us 1 as the answer. So anything raised to the power 0 is 1. 0 raised to the power anything. So anything raised to the power 0 is 1. 0 raised to the power anything is 0. These two are very important for you to understand. Okay. So let's move forward to the sums now. Okay. What are the power of product and the power of quotient property? We have already done this. Okay. Now let's come up to this portion. I have here, it is given square root. Okay, let me first start off with the square root. So if I say this is actually nothing but 2 raised to the power half. Okay, if I write, okay, this is actually 7 raised to the power 1 by 4. If I write something like this is 10 raised to the power 1 by 7. Okay, now from this, if I want to write something inside as well, okay, so if I say 10 raised to the power 2, but I need a square root, that is 4. So what we'll write, what we have learned, 10 square will be like that, and this will be the power 1 by 4. So this will become 10 2 into 1 by 4. 2. So 10 raised to the power half. So this answer will come out to be 10 root. Okay, did you understand this? Sure. Now, first sum. A computer's memory is represented in terms of power 2. If 1 TB terabyte is 2 to the power 40 bytes, how many bytes are in 4 TB? Okay, let's do this sum. It's a very easy sum. So 1 TB is equal to 2 to the power 40 bytes. Okay, so 4 TB will be 4 into 2 to the power 40 bytes. But we also know that 4 is actually nothing but 2 raised to the power 2 into 2 raised to the power 40 bytes. Using product law, we can write 2 raised to the power 42 bytes. That is the answer. Did you understand, guys? Okay. Now, second, let's go on with the sums now. Okay, we have a few sums. We need to solve those sums first. What is the value of minus 1 raised to the power 10111? Okay, so first thing, minus 1 divided by 10 to the power 111. Okay, second thing, first thing, negative sign in the power I have wrote down in the denominator, and whatever power of minus will be, like if I write 1 to the power 19, that is 1, right? If I write 1 to the power minus 5, it will be minus 1. Okay, 1 to the power 4 plus 1, that plus 1 minus 1 thing we have already decided, right? If power, any number power is uh, n. If m is even, the answer will be in positive. If n is odd, answer will be negative. Okay, so for this particular answer, so this is even, right? Even or odd? This is odd, the last is 1, so answer is 1 by minus 1. So the answer will be just minus 1 here. Okay, this is the first one's answer. Second one answer is going to be what? 1 by minus 1 again. Similarly, we have the same answer for both of them. Okay, now if a, no, for the second one there will be no minus here. Let me write it down first. 1 second. First one we have found the answer as minus 1, right? Second one, there is no minus sign here. There is no minus sign here, right? So we just reciprocate it. 1 by 1 raised to the power 1 0 1 1 1. So even if there is an like negative sign in front of it, then we'll, if there is a negative sign in front of the base, then only we will check whether the power is even or odd. Here, no negative number in front of the base, so no point checking whether it will be a positive or negative number. It will be a positive number anyways. We'll have 1 as the answer. If a is any non-zero number, okay, what is the value of a raised to the power 0? We have already decided that a can be anything, but raised to the power 0 will always give us the answer 1. Okay, so we have done these three sums. Let's continue. Okay, sorry, very sorry guys, as you have already seen the answer, so let me try to do it as fast as possible. So 1 by 3, this is what? 1 by 3, 1 by 3 to the power minus 3. Okay, this is actually nothing but 1 by 3. This goes up. 1 second, let me do this much easy for you to understand. So 1 by 3 will go up, right? Will go up. If I write a is equal to a to the power 1 is equal to 1 by a minus 1. Okay. Similarly, if I write 1 by a and this I write minus 1. Okay. This will be nothing but a to the power 1. Okay, because this goes up. Okay. So this is the same thing, same issue. So this 3 will go up and it will be 3 cube. So this will convert into this. Similarly, 4 cube minus 5 square. Okay. So 3 raised to the power 3 is 27. 4 raised to the power 4 is 64 minus 25. So we get 27. See what I am doing. 7 plus 4, 11. 11 minus 5, 6. So first place is 6. Okay. Second, we have 6, 7, 8. 8, 8 minus 6, 66. Okay. We get the answer 66. Okay. Let's see. Okay. Do you guys understand? What did I do? Chalo. Now on to the next sum. So as you can see in this particular thing, we have all the same bases of everything are same. Okay, let's first utilize in the numerator. I'm going to utilize the product form, and in denominator I will do what? I will just impart the 2 inside. Let's do that. I'll do it simultaneously for you to answer it very easily. So x m plus n plus n plus l plus l plus m divided by x 2m plus 2n plus 2l. Okay. Now, how many m are there? 2 m's, right? So x 2m plus 2 n's are there. 2n plus 2l. And in the denominator, it is the same exact thing that is written, right? 2m plus 2n plus 2l. So both of them will cancel each other out and the answer will be 1. This particular thing is same as 2 to the power 4 plus 6 plus 9 If I write 2 to the power 4 plus 6 plus 9, it will give us what? It will give us 2 to the power 19 divided by 2 to the power 19. This will cancel out and give us 1 only, no? So it is the same thing that is happening. Okay. So let's continue. Okay. So this is the answer. Next, let's do this one. So here it is given, we have some values. The value of x is 2 raised to the power 3. Okay. So this is, we can like, either we can do it by substituting the value or we can do it in exponential form. As we are doing exponents right now, we will be doing in exponential form only. Okay. So this is what we have to find out. So let's write it down. X square into y cube to z raised to the power 4. Value of x is nothing but 2 raised to the power 3. So 2 raised to the power 3 whole square. Value of y here is 2 raised to the power 4 raised to the power 4 whole cube. Value of z is 2 raised to the power 5. So 2 raised to the power 5 4. Okay. Next step, 2 3 into 2 6 into 2 4 into 3 12 divided by 2 20. So we have 2 to the power 18 divided by 2 to the power 20. Here denominator ka power is more, so I am writing here 1 by 2 to the power 20 minus 18, 1 by 2 to the power 2, and the answer is 1 by 4, or we can write 0.25 as well if you want to write it in decimals. Okay. So this is the answer for this one. Now, these are a few sums that we need to calculate. Okay. So there are 1, 2, 3, 4, 5, 6 sums. Okay. Let me do the last 3 sums and the top 3 sums for you to do. Okay. Let's begin with the last 3 sums. So this, and this I will do. So let's start off with this one. 3 raised to the power 3. 3 raised to the power 3 minus this entire thing will be an inverse. So this, okay, into 1 by 19. So 3 raised to the power 3 is 27. 2 raised to the power 3 is 8. Okay. This will be what? 19, right? 19, 20, 20, 20, 27. Okay. So the answer here is going to be 1. Okay. So this one done. Next one, this one, let's do it. So it is written here 2 minus 1. Let me first 2 raised to the power minus 1, so it is half, plus 3 raised to the power 0. Anything raised to the power 0 is going to be 1, so 1. 5 raised to the power 1 is 1. 7 raised to the power 2 is nothing but 49, so 7 square. 9 raised to the power 3 is actually 729. Okay. Then after that, divided by this entire thing is divided by 3 by 2. Okay. 2, 3, 4, 5, 6, 7. Okay. So first let's add everything up. Okay. 1 plus 49, 50. So half plus 50 plus 5, 55. 55 plus 7, 29. Okay. So this will be what? 14, 1, 5, 6, 7, 8, 784 plus half 2, 784 into 2, so 8, 16, 1, 14, 15 plus 1 into 2 by 3. This cancels out. So remains with 1, 5, 6, 9 into 1 by 3. Let's see if it's like divisibility rule of 3. What is divisibility rule of 3? Add all the numbers. If the number is a multiple, is getting divided, or a multiple of 3, it is going to be divided by 3. So 5 plus 1, 6, 6 plus 6, 12, 12 plus 9, 21. 21 is divided by 3, yes, so it is going to be divided. 15 5s, 2, 3. So 523 is the answer of the second one, this one. Okay, now let's move on to the last sum. Okay, find the multiplicative inverse of this. So after finding the entire sum, read the question first. They want to know the multiplicative inverse. First let's solve this, after that we'll reverse this. After solving, reverse. Multiplicative inverse is that. What is multiplicative inverse? If I have a number a, what I have to multiply it by, okay, to get the answer as 1. Okay, so a into 1 by a will only give us the answer 1, right? So multiplicative inverse is the reciprocal of the number. Okay, let's do the last sum now. So I have 125. 125 is what? 5 raised to the power 3. So if you forget this, just do the basic prime factorization method. 5 25 5 5, so 5 raised to the power 3 is 125. Okay, similarly 27 is 3 raised to the power 3. Okay, so this portion converts into this 5 to the power 3 divided by 3 to the power 3 into minus 2 by 3. Okay, let's convert this ulta, reverse. 3 to the power 3 by 5 to the power 3. Now let's do one more thing. Let's make it much more easier. Why will we convert it now? Okay, let's put this inside the bracket using the power law that we just understood. So 5 3 into minus 2 by 3 divided by 3 3 into minus 2 by 3. Okay, so this 3 and this 3 gets cancelled out, this 3 and this 3 gets cancelled out. So what do we have remaining here? 5 raised to the power minus 2 and 3 raised to the power minus 2. Now minus minus are there, so this can be written as 3 square by 5 square, right? So